Imagine a world where you could step into a parallel universe or jump back and forth in time. This is the fascinating concept of other dimensions. Now, it might seem like we're stepping into the realm of science fiction or even magic, but we're actually venturing into the world of theoretical physics and mathematics. This is where reality, as we understand it, undergoes a dramatic transformation. The concept of other dimensions beyond the three spatial ones we're familiar with has been a source of wonder and intrigue for centuries. From the ancient philosophers to the modern scientists, the idea of existence beyond our perceived reality has been a captivating mystery. In our day-to-day lives, we experience three dimensions: length, width, and height. We can move forward and backward, left and right, up and down. But what if there were more dimensions hidden from our senses? What if we could move in ways we can't even imagine? These questions have given birth to a multitude of theories, some of which suggest that there might be up to 11 dimensions. These theories have not only challenged our understanding of the universe, but also opened up possibilities that were once considered purely fantastical. The idea of other dimensions has permeated our culture, finding its way into science fiction, art, and even our philosophical debates. It has sparked our curiosity and inspired us to look beyond the obvious, to question the nature of our reality, and to explore the unknown. And yet, despite all the speculations and theories, other dimensions remain largely an enigma. They are a puzzle that scientists are still trying to solve, a mystery that continues to baffle us. We don't have any definitive proof of their existence, nor do we fully understand their implications, but that doesn't mean we should stop exploring. On the contrary, the enigma of other dimensions is what makes them so fascinating. It's what drives scientists to keep researching, to keep questioning, to keep pushing the boundaries of our knowledge. But before we dive into the depths of other dimensions, let's get our basics right. What exactly are dimensions? Dimensions, in the simplest terms, are the different facets of reality we perceive. They're like invisible threads that weave the fabric of our universe. Imagine a straight line. This represents the first dimension, length. Now take that line and stretch it sideways. It forms a square, introducing the second dimension, width. Pull that square upwards, and you have a cube symbolizing the third dimension, depth. These three dimensions are what we humans are able to perceive in our daily lives. Now let's delve a bit deeper into how these dimensions are understood in the world of physics and mathematics. In physics, dimensions are used to describe the position and characteristics of an object in space and time. Each dimension is represented by a coordinate, with three coordinates corresponding to the three spatial dimensions. Mathematics, on the other hand, often uses more than three dimensions. For mathematicians, a dimension is a direction in which we can measure, and there's no limitation to the number of dimensions in mathematical spaces. In our everyday life, we experience the world in three dimensions. We move forward and backward, left and right, up and down. We live in a three-dimensional space. But is this all there is? Or is there more to reality than what meets the eye? Physicists and mathematicians have long contemplated the existence of additional dimensions. These extra dimensions, while currently beyond our perception, could provide answers to some of the most perplexing questions about our universe. They could explain the mysteries of quantum mechanics, the enigma of dark matter, and the riddle of gravity. But what if I told you these might not be the only dimensions that exist? There are theories that suggest the existence of dimensions that go beyond our perception. A fascinating concept indeed, and it's one that has captivated the minds of scientists and philosophers alike. Imagine a reality where, beyond our three-dimensional world, there exists realms that our senses can't perceive, our minds can't fathom. This isn't a work of fiction, but a proposition rooted in science. The concept of dimensions beyond our perception is like a cosmic puzzle waiting to be solved. It's a riddle wrapped in the fabric of the universe itself, woven with threads of space and time, and perhaps something more. It pushes the boundaries of our understanding, challenging us to think beyond the familiar, to question the very nature of reality. This idea is not just fascinating, it's revolutionary. It opens up new avenues of exploration and raises questions that could redefine our understanding of the universe. One such theory that proposes the existence of extra dimensions is the string theory. String theory, a theoretical framework in which the point-like particles of particle physics are replaced by one-dimensional objects called strings. Now, isn't that a fascinating thought? But what does it mean, and how does it tie into our discussion about extra dimensions? Well, to grasp this better, let's take a quick dive into the world of particle physics. You see, in the classical understanding of physics, particles like electrons, quarks, and photons are considered as points in space. However, string theory challenges this notion by replacing these point-like particles with tiny, vibrating strings of energy. These strings vibrate at different frequencies, and it's these frequencies that give rise to the various types of particles we observe. Think of them like the different notes you hear when you pluck a guitar string. Now, here's where things get really interesting. For string theory to work, it requires more than the three spatial dimensions we're familiar with. In fact, some versions of string theory suggest there could be up to 10 dimensions. These extra dimensions are thought to be compactified or curled up so small that we can't perceive them. Picture it like this. Imagine you're looking at a tightrope walker from far away. To you, the rope appears one-dimensional, a simple line. But if you could get closer, really close, you'd see that the rope has an extra dimension. It's not just long, but it's also round. This is a way to visualize how these extra dimensions might be hidden from our perception. But why do we need these extra dimensions? Well, string theory is a candidate for a theory of everything, a single, all-encompassing, coherent framework that could explain all physical phenomena, including gravity. And these extra dimensions might just be the key to unifying the forces of nature. But string theory isn't the only perspective that introduces us to the concept of other dimensions. So, as we continue our journey, we'll explore even more intriguing theories about the nature of our universe and the potential existence of other dimensions. The multiverse theory proposes the existence of parallel universes, each with its own laws of physics. The multiverse theory, it's a concept that feels right at home in science fiction novels, but it's actually a legitimate scientific hypothesis. This idea suggests that our universe might not be the only one out there. It proposes that there could be an infinite number of universes, or multiverses, each with its own laws of physics, each shaping its own unique reality. The multiverse hypothesis is a natural extension of quantum mechanics, the branch of physics that deals with particles at the tiniest scales. According to this theory, every decision you make, every chance you take, could spawn a new parallel universe. In one universe, you might be a scientist making groundbreaking discoveries. In another, a world-renowned musician. And yet in another one, you could be living a completely different life. But how can we prove the existence of these multiverses? Well, that's where things get tricky. The very nature of these parallel universes implies that they exist outside of our own universe, which makes them inherently unobservable. However, some scientists believe that we might be able to detect the imprint of other universes on our own, potentially through cosmic background radiation. Despite the tantalizing prospect of infinite parallel universes, the multiverse theory is not without its critics. Some scientists argue that the concept is untestable and therefore unscientific. Others worry that the multiverse hypothesis, by explaining everything, actually explains nothing at all. Whether you're a firm believer in the multiverse theory or a skeptical critic, we can all agree on one thing. It's a mind-boggling idea that challenges our understanding of reality. It forces us to ponder on the infinite possibilities that might exist beyond the confines of our own universe. The multiverse theory is indeed mind-boggling, but how about the concept of wormholes and portals? Wormholes and portals, as seen in science fiction, are theoretical passages through space-time that could create shortcuts for long journeys across the universe. These fascinating concepts have captured our imagination for decades, often becoming the central theme of many science fiction narratives from Star Trek to Interstellar. Now let's delve into the science behind these concepts. Wormholes, in theory, are tunnel-like connections made out of space-time, the four-dimensional fabric of the universe. They provide a shortcut between two vastly distant points in the universe. The term wormhole is derived from an analogy used to explain this concept. If the universe is an apple and a worm wants to go from one side to the other, The fastest way would be to burrow a tunnel through the core, rather than going around the surface. Portals, on the other hand, are often depicted as gateways to other dimensions or parallel universes. In theoretical physics, they represent hypothetical shortcuts through space-time, much like wormholes. However, portals often encompass a broader range of possibilities, including access to different dimensions or realities. The existence of these space-time shortcuts is based on solutions to the equations of Albert Einstein's general theory of relativity. However, it's important to note that these solutions are purely mathematical and highly speculative. As of now, there's no experimental evidence to support the existence of wormholes or portals. But imagine for a moment if these science fiction concepts were reality. We could potentially reach distant galaxies in a blink of an eye, or even explore parallel universes and dimensions beyond our own. It's a tantalizing thought, isn't it? However, the reality of creating or finding such space-time shortcuts is fraught with challenges. They would require conditions and materials that are not yet within our reach, like negative energy, something that's purely theoretical at this point. In summary, wormholes and portals remain fascinating theoretical concepts that push the boundaries of our understanding of the universe. They represent the intriguing possibility of travel across vast distances, and even to other dimensions. The concept of other dimensions is not just limited to physics and mathematics, it has found its place in art and culture too. Other dimensions have been a source of inspiration for numerous works of art, literature, and popular culture. Imagine a world where the laws of physics are turned upside down, where time and space take on new and unexpected forms, where the impossible becomes possible. This is the world of other dimensions, a world that has fascinated and inspired artists, writers, and filmmakers for centuries. Take, for instance, the world of literature. Books like Edwin Abbott's Flatland, A Romance of Many Dimensions, and Madeleine L'Engle's A Wrinkle in Time have played with the idea of other dimensions, creating fascinating and thought-provoking narratives. These stories often use dimensions as a means to explore deeper themes such as the nature of reality, the limits of human understanding, and the potential for infinite possibilities. In visual arts, artists like Salvador Dali and M.C. Escher have used the concept of other dimensions to create mind-bending works that challenge our perception of space and reality. Their art often features impossible shapes and structures, representing a reality that exists beyond the three dimensions we are familiar with. In the realm of cinema and television, other dimensions have been a staple of science fiction and fantasy genres. Films like Interstellar and series like Stranger Things have used other dimensions as key plot devices, creating intriguing narratives that captivate audiences. Even in music, composers have experimented with the concept of dimensions, using complex structures and patterns to create soundscapes that evoke a sense of otherworldly space and time. All these examples demonstrate how other dimensions have permeated our culture, influencing the way we think about space, time, and reality. They allow us to imagine and explore worlds beyond our own, pushing the boundaries of our understanding and perception. While art and culture have their interpretations, theoretical physics and mathematical models have their own ways of understanding other dimensions. Theoretical physics and mathematical models have played a crucial role in our understanding of other dimensions. Theoretical physics is a realm that pushes the boundaries of our understanding, venturing into the unknown and challenging our assumptions about the physical universe. It's like the backstage of reality, where the fundamental laws of nature are written and rewritten. In this realm, dimensions are not just up, down, left, right, forward, and backward. They can be curled up, hidden, or even infinite. Theoretical physicists use mathematical models to explore these possibilities, creating a sort of blueprint for reality. These models are like maps of the universe, providing us with a structured understanding of how things might work in other dimensions. One of the most intriguing theories to emerge from theoretical physics is string theory. It suggests that the fundamental building blocks of the universe are not particles, but tiny vibrating strings of energy. And here's the kicker. For the math to work, string theory requires the existence of 10 or even 11 dimensions. Now that's a mind bender, but it doesn't stop there. Theoretical physics also explores concepts like quantum entanglement and the multiverse theory, ideas that could further suggest the existence of other dimensions. Quantum entanglement, for instance, has been described as spooky action at a distance, implying a connection that exists outside our conventional three-dimensional space. And then there's the multiverse theory, the idea that our universe might be just one amongst an infinite number of parallel universes, each with its own laws of physics. If true, this would truly redefine our understanding of reality. Theoretical physics and mathematical models are our best tools for exploring these mind-boggling concepts. They guide us in our quest to understand the cosmos, allowing us to make predictions and hypotheses about the nature of other dimensions. As we stand on the brink of new discoveries, the mysteries of other dimensions continue to captivate us. Who knows what secrets we might unveil as we delve deeper into the realm of theoretical physics and the fascinating world of other dimensions.